Hello YouTube family, James Green, Short Series Shenanigans. So, today is going to be a very basic video on using high-speed steel tool bits for cutting in aluminum. Now, the reason I'm doing this is I've had a viewer named Larry Robinson. Shout out to you there, Larry. He recently purchased the exact same lathe here, the Grizzly G0776. Now, when I first got this lathe, after I did it and had it for a while, or I did the initial break-in, and I've had a lot of people ask me in those first couple of videos, man, that thing was noisy. It was the break-in oil that I was using, because when the lathe came, it had no oil in it. So the break-in oil that I used, very, very noisy. We ran it for a little bit of time, and we put fresh oil in it and other stuff, and she runs quiet. So since then, a lot of time has passed. I've had great success with the lathe, and I've had a surprising number of people contact me in reference to the lathe. Excuse me. They were interested in purchasing the same one. I even had a gentleman ask me if I had to buy this same lathe again tomorrow because of, let's say, unfortunate circumstances, fire, whatever, or I've moved somewhere else. Yes, I would buy this same lathe. For me, as the garage guy, or if you're a small businessman, this is just an awesome machine. It's great. I enjoy it. So Larry reached out to me. He said, hey, I got some questions. Larry is a little bit new to the machining world. He's been a fabricator and repairman his entire life. And so he has some questions, and he was needing some high-speed bits, and I said, well, you know what, let me do a video for you. And this isn't just for him, but anybody else who is new to machining. Again, you guys, if you guys have been doing this for a while, this is going to be old hat, and I'm taking it from an approach of, I like to take the math out of it. And I've talked about this before. I try to keep it simple, because if you're new to it and people throw numbers at you, surface feet per minute and, all this, and you're new and it's overwhelming. I like to approach it from, it's fun, and as you learn more, then you understand the reasoning behind it, the math, why you're turning as fast as you're turning, why you're feeding the tool as fast or as slow, vice versa. Again, this is just a very basic, rudimentary introduction to using high-speed steel tooling in aluminum. We're just going to be using some 6061 aluminum T6, some basic tools that I've ground up. These actual tools are going to Larry. And so if any of you else out there have any questions, you know how to get a hold of me. My public email address, eagledustoff37@gmail.com. Now, I am going to call out positions on the gearbox over here. So those of you that know, when I go to call it out, and I'm sure you'll play the video back several times, okay, on the gearbox, I'll call out the positions of high-low, what RPM, and then the way it's set up. If you have this machine, you already are familiar with this area. It's going to be A, B, C, D, E, or 1 through 5, and then we have position 1 and 2. And then the feed chart is over here, and that varies. Now, we are going to be, it's the standard setup from the factory, to where this is set up with the 24 tooth on top and the 48 gear tooth on the bottom. So it's still in the factory settings. I have reversed them whenever I have to do some coarser threads at times, or some metric threads, but for the vast majority of my stuff that is 16 thread per inch or finer, you leave it in the factory setting, and that seems to work the best for doing the vast majority of the turning. So I'll go ahead and move you guys to the end so you get a basic view of what's going on, and I'll give you an up-close shot. And there's lots of other videos out there on how to grind tool bits. I've done some on my channel on how to use a carbide grinder. There's also going to be one out there on how to use here's a quick shot. I've done one on how to use the carbide grinder, which you can use that on high-speed steel tooling, or anything you need to sharpen. If you want to freewheel it or use a specific angle, you can use that. And I am going to do one using the old Black & Decker pedestal grinder. That's 110 volt original. It hasn't been changed. It's a just post World War II vintage. It's 10-inch pedestal grinder, 10-inch wheels, so it works great. So I'm going to go ahead and get you guys a decent angle here so you can see what's going on with the action. And you know me, live and unedited, so there seems to be a good angle. And I've already been playing with them a little bit just to kind of show you guys what we got. Now, if you're interested, you can actually build your own tool holders depending on what size you have, 0XA, AXA, or mine are BXA or 200 series. Then you have CA, and then you have DA, which are the big, huge Adam Booth size. Which, if you're watching this, you probably know about A-Bomb 79. Adam Booth, real great guy. Go check his channel out. He's got a very, very big following, and he's a very, very good friend of mine. So, if you want, that would actually be a good thing. If you've got a mill, you can get you a dovetail cutter, and you can actually cut these and make your own if you want. They can be 1018 steel or A36. They could be a mild steel. They don't have to, these aren't hardened, so they don't have to be hardened. The holders don't. So that's a good simple project. You can make your own. This is one, I've had a couple that were given to me, and they were missing all the screws. It was missing this screw, this, and this. And I've actually made all these and made it functional. I've done that to a couple of them. Anyway, I'm going to go ahead and get started. One tool that's really, really handy to have, and I've showed this several times. I've had this tool even when I had my other smaller Grizzly G0676 lathe. Edge Technologies. I can't say enough about this tool. This tool right here, and I'm going to demonstrate it a lot, is very, very handy. If you want to invest in a good tool and you're just starting out, you can get this at several places. I know All Industrial Tool Supply has it. They're worth it, trust me, and I'm going to demonstrate that. So, we'll go ahead and get started, and I'll just go with what we got in the tool holder here. So we want to set our tool height. Now, I purposely set this off the incorrect height so I can demonstrate the tool, and we'll go ahead and set it in here. We want to make sure we're, perpendicular to everything. And so what you actually do is you take the V side of the material and you bring your tool down here. So you have the very end of it, or what would be the cutting surface. On this one, it's going to be right about in the middle here. And let me zoom you in just a little bit so you guys can see exactly what I'm talking about. Okay, bear with me, a little camera movement here. Okay, all right, so let's see, is that in frame? All right, I'm trying to look at my viewfinder here. All right, that's in frame. Let me go up just a hair. Let me loosen that. Alright, so demonstrating how this tool works, with the back, you slide it in there, you drop the tool down on top of the highest part of the tool, which I know right here in the middle it is. You can see the bubble, it's off level. All you do at that point is you want to go ahead and lower it. Let me loosen this up, there we go. Helps if you loosen the tool holder. And then you just proceed to adjust the adjustment nut on your tool holder until it comes down right in between. Whoop, went down a little far. And then go ahead and come back up. And we're set. And what I like to do, just double check it, because see, when you lock it in, it'll raise up a little bit. They'll do that. And then lock it, and it comes up a little. Now, it doesn't have to be exact, but I like dialing mine in, so I know when I lock it in, it's going to pull it in level. Okay, then I go ahead and put my lock nut down, and we're good to go. Now, some people like to, well, let me just get a 6-inch scale works fine. I've heard that argument a lot. It does. It really does. If you notice, I wear glasses. Several of you out there wear glasses. When you get older, it's a little harder to see the light, the size, the tiny, the whatever. This takes the guesswork out. It's easy to see a bubble. You can line it up. The graduations are marked on the bubble there. It's real easy to see. And so, my dogs are, there's an intruder. I love my Dachshunds. Anyway, so it's easy to see. Even if in low light, because depending on where you have your, I've worked really hard to get good lighting, but if you have really bad lighting, let's say you're in a corner of a garage or a shed, and you have very, very limited lighting, for that tool right there, it's worth it. So, especially if you're limited on tool holders, and you have to swap, you have something going on, pardon me, I got something in my eye, and you need to swap tool holders or tools. I'm sorry, you need to swap your tool within your tool holder. It's very, very handy for that. And until, you know, your budget allows, you either make or purchase more tool holders. It's phenomenal, trust me. It's a tool you need to invest in. So, the one we've got in here right now, okay, we've got it adjusted and set. We'll go ahead and pull it out. It's just a general radius tool. Nothing fancy. You can grind your own. I mean, this is a general style that I've had around for a long time. Nothing fancy. You can make your own. There's nothing particular about this. Now, the tool was originally ground, get in frame here, so that this cutting edge is taller than this. So when it comes in, and you guys will learn as you practice with form tools, they'll create rounded items. Before we use this one, let's go ahead and take some of this other material off, so we have to create another radius. Several people have showed this style. This style of cutter with a chip breaker ground into the end has been around a long time. You know, you get your relief on your side here, and it's just a very rudimentary cut, and you grind a little groove in the end there, and that allows the chip to curl. Now, depending on how wide and how big and how deep, it varies on your material. These are typically for really soft steels, non-ferrous materials like aluminum, brass, bronze, stuff like that. I'm going to run this at 755 RPM, and this is just going to be, I'm going to hand feed this just to show you, and we're going to go ahead and actually, yeah, we'll go ahead and do this, and we'll turn some of this material down. You can see how it works. Take the e-stop out. Oh, might help if I put it back on high. There we go. All right. Let me zoom you guys in here a little bit, and you can see what we've got going on. I don't want to get too close. And we'll just start here on the end. Call that 0. And do a manual 0 here. Dial in 20 thou. Up here on the DRO, there's 20. Alright. Making a nice, it's somewhat of a long stringy, but it's still breaking it. Okay. Alright, you don't want them really, really super long, but if you get the feed, and you've got to play with it, that's not too bad, but it's not, they were coming out to be about this long or so after a bit, and breaking. Okay, that was 20 thousandths. The heavier you feed them, the more they're going to create a long stringier chip, or at least this style setup. I'll demonstrate. We'll come over here. I'm going to dial in 30, okay? You'll notice a difference. Alright, see that? Long, let me back the camera out here. You guys are starting to get the idea, okay? The deeper the cuts on some of these, This is what you want to avoid, okay, and that is a problem. Depending on your speed and your feed and everything, you have to play with it. There's not a certain set magic number. That's what we want to avoid. In each tool, every time you use it, depending on the wear pattern, it's going to affect. You have to play with it. Even steel, you've got to play with it. What works good? You notice when we did a shallower cut, but the deeper the cuts with this high-speed steel, it's going to do that. Aluminum has a propensity to get stringy. You just have to play and experiment with speeds, feeds, and different grinds. But on the lighter ones, the heavier, deeper you go with a high-speed steel, the longer, stringier it's going to get. You can even go and slow way down on a feed rate and change things. You just have to experiment, and that's the main thing I wanted to give you an example with that type of cutter. Now, let's just change tools real quick here. Okay, we're going to change cutters. I've got one here that's got a grind cut across the face of it. Okay, and that's a facing tool. All right, it's still got your basic geometries to where, you know, this is our leading edge. This is the lower side, and you can also use it to come in and dress up, and you can also face. And it's also got on the back side for other materials, it's got the same very basic rudimentary that's in all the books. Your very basic cutting for, you know, cast material. It's just very basic grind. That'll work too. I'm a big fan of putting grinds on each end of my tool so I can pull it out and flip it over and change over real quick. So let's change out this one real quick. Alright. Now we're going to an obviously smaller tool. It's going to change things. We'll slap it in here real quick. Get it fastened down. I always try to have at least 3 of the fastening screws hold it in place, or the dog boot screws. Okay, so we're set. Come in here with our tool, because we've got to change our tool height. Get that loose. We know we got to come way up. Alright. Same thing. I'll leave you guys back at a distance so you can see what I'm doing here. Pull out here on the very leading edge. And what I'll do sometimes is I'll pull up quite a bit by hand, hold it up there, and then I fine tune and get it down in place. Once you've used a tool a few times, I always like to check. Sometimes if you set them a little, or on my tool post, if you set it a little low and then you lock it in, it pulls it into the correct height. So we're set up, okay? I'm going to leave you guys, well, let me zap you in just a little bit here, okay? Alright, and so we're going to demonstrate. It's going to be a little hard to see because of the angle, but this is going to be a facing tool. We're just going to face some of this off. Now we know we're sticking out kind of. Matter of fact, let me shorten this up a little bit so we're not sticking out as far. Because you get sticking out too far on aluminum and items and you can cause problems. Now what we're going to do, we're going to face a bunch of this off. Now I can tell I'm just a little low, which is fine. And that's how you also find it. You can play here on the end and clean up the rest of the there we go. Alright. So we'll call that 0. And we'll slide over 50 thou. Takes it right off. Another 50 thou. Faces it right off. Alright, that's aluminum. There you go. I'll pull this one out. It showed you the basic chips we were making. Try to get in camera here. They weren't very long. Alright. And here's the tool we were using. I'll try to get the camera to focus on it. Okay. And it's just a groove across the end of the tool. Again, you can experiment with your grinds. Back the camera out here a little bit. You can experiment with your grinds and find out what works well, and there you go. Alright, on to the next. Now, I've also created some threading tools. You can thread in aluminum. It's very, very, very tricky. Aluminum strips out so easy doing fine threads in aluminum. From my personal experience, if you have a die for it, it's better to use a die in aluminum. Depending on what you're doing and making, if it's a fine thread, it's very, very, very tricky to learn how. If you're going to learn how to single point thread, I recommend getting you a bar of like 1144, 1145, or some 4140. Learning in 1018, it's really, really gummy. It doesn't machine well. It's just a general purpose material. Get you some 8620. That's a good material. It's relatively inexpensive, and that is good to learn with. Don't try to learn single point threading in stainless. It's very, very tough. Or in aluminum. Get you a good basic steel. Don't get it too soft. Don't use some unknown really soft general purpose steel. You won't get a good finish. The threads won't cut right. But you get some of those that I recommend, and there's lots of videos on how you single point thread out there. I've done some in the past on how I do it with my older lathe. I approach it from the same way with this one. So we'll go ahead and go back to our forming tool here that we made. Same thing. We already set the tool height. You saw that. I'm just going to go ahead and zip you guys in here a little bit. Alright? So you guys can see the cutting action. Now, I am going to talk you through, because form tools, whether you're creating a radius, external concave, or convex, you can get it to where it'll chatter and you'll hear. You've got to play with the speeds and feeds. So you're going to see me kind of work it through. You don't just plunge straight in. It's like carving or whittling. That's what I call it. Still, we're at 755 RPM. And you come in here and see, I'll get some of the back. What I found works well is feeding left to right, and then also kind of coming out with the tool. You just kind of sneak up on it. A little here and a little there. Till you get your desired shape, if you want it the shape of the tool. And we're taking small enough stuff on this, we don't need lubrication for aluminum. For what we're demonstration purposes, I'm leaving, we're not doing heavy turning. And once you get down, and you get to where you want, you can see the type of chip you're creating, okay, because you're pulling, they get really, really fine. If you plunge in too hard, you can run a risk of bending the part or snapping the tool. Now I know I'm going to have people ask, why didn't you use cutting oil? One of my favorite cutting oils or lubricants for aluminum, WD-40, whether I'm doing it on my mill, end milling, face milling, drilling, tapping, even the lathe work. I left it off because we were just doing some light cuts to demonstrate, but WD-40 works. It leaves a great finish. But all that was done right there, and I was hand feeding the tool. Depending on the surface finish you want, it's all about the tool, the speed, the feed. In my experience, and this is just some 1-inch 6061 T6 aluminum. When you go to 70 to 75, I've had 2 different sticks, it might have been a different batch, I don't know. They'll cut a little different. You just have to play with it. Once you get the tool geometry down, a sharp tool, a crisp tool with a crisp edge is going to create a good cut. This was purely a demonstration, general for those of you that are new. There's a lot to learn. I could spend hours and hours and hours showing different tools and different cuts. That's the fun of machining. I do it from a hobby or a small one-off job shop. I do a lot of stuff for veterans and old guys, and hey, can you fix it? Because we're in a throwaway society right now. I was raised that you reuse any and everything you can, and then when you can't reuse it anymore, and then you turn it into the recycler to be reused. So that's the fun of machining, is learning. You can't always learn everything from reading a book or watching a video or listening to someone lecture. But I always try to make my videos interesting, giving the basic information, keeping it fun. There's so much to learn. I mean, you can sit and read that machinery's handbook and you'll be like, I'm overloaded. You know, when people start throwing feeds and speeds and, you know, cubic feet per minute and all this, and the numbers just, it's overwhelming. We want to make it fun. We want to make it interesting. And as you learn more about it, then you have time to sit back, the downtime, and you pull out, you know, our new modern digital phone. We're all sitting here scrolling. It's like, okay, that's why I am, okay, okay, I remember seeing someone did a video that explains why this and that and the other. And then you start learning surface feet per minute. Generally, your materials like aluminum and brass, the softer materials, a fast RPM, a sharp tool with a positive rake, you're going to get a good finish. You're going to get desired results. And you'll learn on your passes. Sometimes tools like a heavier, thicker cut than a really, really light. And you just learn as you go. There's a myriad of, and once you get into carbide inserts, that's a whole nother ball game. So I hope this has been enjoyable to you guys. There's more videos to come, and I'll demonstrate stuff like this. But these bits, Larry, they're going to be in the mail. They're going to be headed to you along with some other goodies. And if you guys have any questions, feel free to reach out. I'm on social media, Instagram, Twitter, and Facebook. Again, my public email address if you have any questions, eagleduffstuff37@gmail.com. So we also like to give our channel sponsor, All Industrial, shout out and say thank you to guys out there. They're in California. They do ship worldwide. They're a small little 8-man business out there, and they're a sponsor of this channel and the Summer Bash. And I like to give them a shout out every time because they're phenomenal people. You can get high-speed tool bits from them, blanks to grind your own. You can get your own grinder like that and other tools. Get on their webpage, www.allindustrial.com. On the left-hand side of the page, they've got a area called Current Sales Flyers. You can download a free version of the Master Catalog in PDF format. You can also call and request a free Master Catalog, and they will send you one. So give them a call, find out what you need, and you know, there you go. Get out in the shop, practice, practice, practice. That's the only way to do it. And don't be afraid to make a mistake, because that's how you learn. You know, that's the only way you do it. So thanks for watching. Like I always say at the end of my videos, and I mean it, take care of yourself and take care of your family, because remember, at the end of the day, you and your family is all you got. Until next time, get out in the garage, play with some high-speed bits, grind you some up, and learn what the fun is all about. We'll talk to you later. Bye-bye.